Alright, hello, my name is Juan Romero, and this is a really short video just kind of touching on reasoning models. Um, Nothing too in depth, just kind of uh, touching on these types of models. Okay, so now first we have, well, I want to talk about OpenAI's O1 reasoning model. Well, O1 is a pretty big model, so in terms of actual speed, it is a little slower than other models like GPT-4, right? Like the O1 Mini, and other models like that. But the thing about O1 is that it's actually really good at reasoning. Okay, so essentially, what a reasoning model is the model thinks every time before it outputs a response. It does this by producing a chain of thought to explore different answers while also verifying them. So it's essentially a type of reinforced learning, right? Kind of thinks of a response. It can backtrack and retry answers if it thinks that the answer that it's initially thinking about isn't the right one. Okay. So actually, what's interesting is that with these sophisticated reasoning models, actually less context is necessary for the model to provide a coherent and correct response. Now, this is just a little example, right? Kind of what um, kind of like reasoning models do. Reasoning models have been around for a minute, but and a little example is here with the chess, right? So essentially, let's say we feed it in this current position. Um, what uh, what the model is going to do, or in this case, this model, it's going to try out in this 3 by 3. It's going to try the all the possible moves that it can make. So as the knight moves, obviously it moves like an L. So from the current position, it can either move to the top left or to the top right. And now from there, it's going to give a score. Why is it going to give a score? Because we can see, I don't, if you know how to play chess, you can see that right now the black knight cannot take the white knight on the left side. So it has a score of 0. But on the right side, if it does that move, we can see that the black knight can take uh, the white knight, right? So let's focus on this right side, for example, right? Now, our final evaluation score is going to be actually -3, right? Because if this happens here, the black knight took the white knight and or left without pieces, right? Now that's all. There is a possibility that the black knight moves in a way where it doesn't take the white knight. And then moving over to the left side, both of these outputs from both of these outputs result in the black knight not being able to take um, the white knight. So taking this into consideration, you'd assume that there's basically there's a chance that you might get eaten, right? There's a chance that the black knight might take the white knight if you move like on the right side, but there's pretty much no chance that the black knight is going to take the white knight if you move like you did, like the model did on the left side. So more than likely the model will choose the left side. So so this image here is kind of it's kind of interesting because it's kind of showing us a chain of thought, right? A little an example of what the model does. So it's given this string. It's given this string right here, this encrypted string, and it's telling him, and this is saying that this string translating in English, translated to English, is think step by step. And then it's saying use this example above to decode now this new encrypted string. And so you can see that kind of the thought process here on the right side. So it's kind of thinking to itself. It may be an anagram or substitution cipher or something like that. And then it starts developing its thesis as interesting. It seems that the ciphertext words are exactly twice as long as the plain text words, right? And if you notice, they are. This first encrypted word is twice as many characters as this word think, right? Step, again, and so on. And then it kind of tests the hypothesis, right? So like I said here, right? Less context is necessary for the model to provide a coherent and correct response. There is really no context. There really isn't any explanation right? The user didn't tell it, I'm going to give you an encrypted string. I want you to, um, no, it didn't say that these words were twice as long as the English translation. They didn't say, nothing like that. There's not a lot of context here, right? You just gave it an encrypted string, you told it what this means, and it says, use this as a reference to decrypt this one, right? So back to the hypothesis. So the hypothesis is saying maybe we need to take every other letter or rebuild the plain text from the ciphertext accordingly. Okay, so it says let's test this theory. But then it realizes that it has 21 letters. Okay, but in total we have 22 letters. So it by itself it starts to realize, wait a minute, this probably isn't an answer that I should give. So let me backtrack. Let me come up with another hypothesis. And then it says alternatively, maybe the average of the two letters corresponds to T, right? And then by these two letters, you can see that it's actually talking about O and Y. So 15 plus 25 divided by 2 is 20, which is T. And that makes sense, right? This is T, and then I didn't do the math, but I'm assuming F plus J divided by 2 is H, right? And then so this is how it's coming up with a hypothesis, and this is how it's you know this is the answer that it's going to give, right? Now, another interesting fact about these advanced reasoning models is that they tend to perform better when they're allowed to think, backtrack, and verify their ideas rather than simply applying, your standard reinforcement learning and after training, and then using the trained model for inference. You can see here on the left side that this is kind of using just reinforcement learning, after training the data. And in its right side, you can see that this is actually at test time. Okay. At test time, this model is thinking, giving outputs, and you can see that we're actually getting a steeper line of accuracy, right? We're getting more accurate if the model gets to think rather than from this trained model from reinforcement learning. And then there's just another image here that we can see that um, GPT-4o, while GPT-4o is a really good model, O1 is a bigger model, and like I said, it might be a little slower, but because of the fact that it is more advanced in reasoning, right? O1 gets allowed the time that it needs to actually think. We can see that in math, right? In exams, things like that, it just the O1 performs better simply because of the fact that it is allowed to think.